Hello guys, hope all of you are doing great. In this part of the video, we'll be learning about the Python function that allows a Python program to take input directly from the keyboard. And also, we'll be learning about a few data type related functions which you will be using quite frequently with these input taking function in Python. Okay then, let's begin today's part. Consider this program. Here in a variable A we have stored 10, in another variable B we have stored 21, and in C we have stored the sum of A and B, and then at the end we are printing the sum. If I execute this program, you will get a correct output. This program is basically adding two numbers and displaying the sum of those two numbers on the screen. This program is good, this program is correct. But there is one problem with this program. Every time I execute this program always shows us the sum of the same two numbers. If we want to compute the sum of two different numbers, in that case what we have to do is we have to change the program itself. Let us say, for example, if I want to now know what is the sum of 10 and 30, I have to change the program itself and then again execute the program to see the output here. It would have been nice whenever you execute this program, the program itself asks the user to enter these two numbers, like whatever it is the value the user wants in A, whatever it is the value the user wants in B. And once the user enters those two numbers from the keyboard, then the program shows the sum of those two numbers. Right? And this can be very easily done in Python using one function, and that function is called the input function. Let's first learn about this input function, like what this function is, how it works, and then we'll come back to this particular program and we'll modify this program so that whenever we execute this program asks the user to enter the numbers from the keyboard, and once the user enters the number from the keyboard, then this program displays the sum of those two numbers. Okay, then let's start with this function input. So for example, we write here x is equal to input, and that's all. We can write it in this way. Let's execute this function and see what happens first, and then we'll uncover this input function layer by layer, something like that. Don't worry. Okay, when we write x is equal to input, then what happens is, first thing that you notice here is that this cursor is, it is sort of showing you that the program is busy. And right now, in which line the program is busy, you see this green arrow mark here. It is telling you that the program is currently executing this particular line, and that's where it is busy. The program is not yet over. And also you see a new thing here, like a sort of, the cursor is blinking here. It means that the cursor the program is sort of waiting for the user to type something from the keyboard and press the enter key. Okay, so until and unless the user types something from the keyboard and presses the enter key, the program will remain in this state forever. Got the point? Okay then. And then say for example I type something, I said something. Okay, I can type anything here. Say for example I type here XX21. I'm entering here a string that contains 4 characters, x, and 2 and 1. And as soon as I press the enter key, what will happen is that whatever, see here, this busy thing and showing this prompt to the user to enter something from the keyboard, all these things are happening because of this particular input function. This input function is responsible for all this. As soon as I press enter key from here, from my keyboard, what will happen is whatever it is the string that I typed from my keyboard, that will go to this variable x. Okay, let's see. Let's press enter key and see. As soon as I press my enter key, you can see that now the program is terminated. It means that as soon as I press my enter key, the input function is over. It received the input from the keyboard and it stored it in the variable x. And done. And that was the program that we wrote. Here you see this xx21, it is not the output of the program. It is something that you typed, and that's why it is here. Okay, if you want to see what explicitly, like what is the value of this variable x, then you can print it actually. Say for example, you can write print x, and then again let's re-execute the program and see. So again, see here, the program is busy. It is busy in executing this particular line, and this input function is showing you this prompt where the user has to type something. So for example, I type here now TRE, something I'm typing from the keyboard, okay? And then print x. As soon as I press this print x function will be executed only when, see right now the Python interpreter is busy in executing this particular line. and it will remain there until and unless I like press the enter key from my keyboard. It will always remain in that particular state, and as long as this particular statement is not over, this statement will not be executed by Python. Got it? Okay, so here suppose I write TRE and I press enter. As soon as I press enter, that TRE will go to X, and after that print X will be executed, and as a result it will display me TRE on the screen. Let's see. Here you see, I typed TRE, I pressed enter, it went to X, and then next line is print X, so it is displaying me TRE. Clear? Okay, let's see another example, like not another example here itself. Let me write something like this here, print, and then I write here hello. Okay, now let's execute this program and notice something about this, learn something more about this input function, and or at least let's get some more clarity about this input function. See, when I executed this function, this program is busy because of the execution of this particular line, and this instruction will not be over until and unless I press my enter key from the keyboard at minimum. And since this particular line is not yet over, Python will not execute any of the instructions which are there below that particular line in the program. Here in this case, the next line that is to be executed is print hello, and we all know like what happens when it executes, like in Python when you write print hello, it means it displays hello on the screen. But we are not seeing any hello on the screen right now. And why is it happening? Because of these top down, because of this execution process from top to bottom. Whenever you are executing a Python program, it will always start from top, and it will take one instruction at a time. So if one instruction is not over, it will not take any other instructions below that particular instruction. It will take the next, once that particular instruction is over, then only it will go for the next instruction. And once that is over, then only it will go for the next instructions, like that. All right. So right now, since it is busy, it will not be taking this instruction for execution. And when it will take this instruction for execution, when this particular instruction will be over. And when this particular instruction will be over, whenever the user presses the enter key from the keyboard. The user can write something here and then press enter, or the user might not write anything, simply press the enter key. Then also it's fine. Got it? Okay, now see here, I didn't type anything from my keyboard, so nothing went into X, but the next line was print hello, so hello you are seeing, and then print X, so nothing has to be displayed actually, simply a new line is displayed. Got it? Clear? Okay, let's learn about another thing about this input function, okay, before proceeding further. And what is that another thing is, okay, let me write another block of code here, and then I write here X is equal to input, and that's all I write, and I execute this program. Then what will happen is, it's just the cursor is sort of blinking there, and it's waiting for the user to enter something from the keyboard. But the thing is that whenever it is like, whenever your program is waiting for the user to enter something from the keyboard, as a programmer, like what input you are expecting from the user, but the user doesn't know, right? I mean, what to enter. Say for example, if you go to an ATM machine, there you have to enter a PIN number, and you see a message above the above the place where you enter the PIN number, like enter your PIN number here. Or whenever you go for a website or anything, you see like, okay, this is the place where you have to type your username, this is the place where you have to type your password, right? Without those levels, it will be very much confusing, isn't it? Like where to type the username, where to type the password, and what to type there actually. That will be a confusion actually, isn't it? Same thing is here. Like this is just one line instruction, like here we are just doing some demonstration of the input function, so I can type basically anything. But when you are writing a valid program, and obviously your program sometimes might be used by other people also, they might execute your program and can see the output of the program. That time, if your program simply displays this a text box, nothing else, those other users will not know exactly like what to enter there, whether they should enter their number, what type of number, like this type of number or this type of number, or whether they have to type the name of their country, or whether they have to type the name of their planet. They will not know that thing, right? So for that reason, what we have to do is, it is a good idea that whenever you are using input function, at the same time you display, along with that you also display a message to the user, okay, like what you are what your program is expecting at that point. So to do that thing, certainly you can do something like this, like say for example here, suppose I'm expecting the age of the person, so I can write here like print enter the age, and then I can run it like this. So this time at least I have an idea, like the user will have an idea, okay, here the program is asking the age of the person. I can write here 32, and I press enter, and done, gone. This is okay, this is fine. In this way also you can solve the problem, but this input function itself has an inbuilt feature. You don't need this extra print function. Actually what you can do is the same thing you can achieve in this way also, that x is equal to input. In this input function only you can specify what message that you want to display to the user whenever it is showing you that blinking prompt. So you can write here like enter your age or something, and then run. More or less you're getting the same output, but the thing is that you are using print, means it is by default it enters a new line character. That means every print displays every print displays in a separate line, like here, like enter the age, it considers like this is one line, and whatever it is to be displayed, all will start from the next line, and that's why this 32 is coming here. I got the point. And other than that, everything is same. Like see here, it is displaying you this enter the age, and then this cursor is blinking here. So what is the moral of the story is that yes, you can write a print function, then you can ask the user to enter something, or directly using this feature of input function, like inside in the input function itself, you can pass the message that you want to display on the screen when your program waits for the user to enter something there. Clear? Okay, so for example, again I write 32 and press enter. Now another thing you see here, if people have, like, I guess things are clear up to this point, and then I move to the next point. Actually not next point, the same point only. Let me tell you something more about it. Okay, let me start with this thing. X is equal to input, and the same thing I'm doing here. I'm writing print hello. If I execute this program, you know what will be the output. If I write whatever I write here, means it will wait for me to enter something from the keyboard. As soon as I press enter, it will display hello on the screen, right? But here you see my point about what am I talking about is this x equal to. Is it really a part of the input statement? No, it's not a part of the input statement. That is, if you write this way also, the program will work fine. If I execute this program, then also it will ask the user to enter something from the keyboard. I write 43 and press enter. Once you enter the thing, here only difference is here, if I write x equal to, then what will happen is whatever the user has entered, it will go to x. But if I don't write that thing, whatever the user has entered, it will not go anywhere. I mean, the program will not remember it. It will simply lose it. Like, okay, it will wait for the user has entered something. As soon as it receives that thing, it throws away that thing, and it continues. Something like that. But if you write this x equal to, it receives the program receives the input from the keyboard, and at the same time it stores it in a variable for future reference. Now if you don't store it in this way, later on if your program needs like what the user has entered that point of time, you don't have any reference here, right? So if you want to reuse, like if you want your program to remember what the user has entered, then most of the times whenever you are using function input function, you will be actually storing the the entered value by the user in some variable, so that later on if you need, you can use it. Say for example, this time I'm using it to display it on the screen. So whatever I write here, whatever I enter here, say for example rew, as soon as I press enter, it will go to x, and then print hello will display hello, and then print x will display me whatever I enter from here. If I entered rew, it will display rew again on the screen. Let's see, hello and rew. Clear? Up to this point, if things are clear, now we can move further. See, although we have learned about this input function, like how to take input from the keyboard, although we have learned that thing, but yet we are not ready to modify this program as we have discussed it, at the beginning. I mean, yet we need to know a few more things before actually converting this static program to a dynamic program. Static program in the sense like it always gives you the same output, it always performs the same computation. Dynamic in the sense like whenever you execute the program, it takes the input from the user, and then based on those new inputs or based on those inputs given by the user, it generates you the output. Okay, things changes in in this dynamic version of the program. Okay, let's now like learn about those extra things that we need to know so that we can come back here and finish this program. Okay, now let me tell you something about data types in Python. Okay, let's say for example we have a variable a where we store 23, but we store this 23, we write this 23 within this double quotation. Okay, and another variable we have b where we again store 23, but this time we don't write this double quotation around this 23. So this time for Python, these 23 is different from this particular 23. This first 23, the Python interprets it as a string. It means whenever you write something within double quotation, then Python interprets that thing as a string. A string is what? It is nothing but it is a collection of some characters. Okay, so you can write 23 or you can write 2x3. So sorry, here, not here. 2x3, all these are all strings for Python. Okay, this is if you write this double quotation around it, it will become a string. But if you don't write double quotation, it will become a number either, or it will become a variable name. Say for example, if you write c is equal to, say you don't write double quotation and simply write abc. Okay, in that case Python will think, okay, this abc is a variable name. See, you might have seen me writing somewhere c is equal to a plus b. We didn't write double quotation around this a plus b, so it will become an expression if you don't write it. Or if you write b equal to 30, we don't write double quotation around 30. It means we just want to store the number 30, not the string 30. Okay, so here that's the difference actually. See, although you store more or less the same thing, it is like a equal to 23, b equal also 23, but for Python these two are completely different things. One is 23 string version and one is 23 the number version. See, let me give you an example. Like say for example, you consider a PDF file, right? A PDF file, and you take the snap of the PDF file, a image version of the PDF file. Although they look very much similar, I mean identical, right? I mean, if I show you a PDF and the image of the PDF, they look same, right? I mean, we read them, like the content of those both these files are same, but the thing is, their format is different. The way they are stored inside the computer, the things are different. That mechanism is different. Same thing is more or less, the same example or same way you can think here also. Although it is 23, 23, but the thing is that, it is a string 23. It's not the number 23, and it is the number 23. Okay, both these two values are actually stored in a different way in the computer memory, and they are actually interpreted in a different way. I mean, okay, let me give you an example. Let me give you an example like how they are interpreted. I mean, where this difference comes, right? So for example, you write now b is equal to b plus 1, and then you print say for example b. Then what will happen here is forget about a for the time being. Okay, b is equal to 23, then you are writing b equal to b plus 1, print b. As you can guess, like b is 23, 23 plus 1 is 24. You have stored it in b, so printing b, at the end it will print you 24. As expected, isn't it? Now here what we're doing is we're adding 1 with the value of b, which is again 23. So 23 plus 1 is 24. It is again stored back in b, and at the end we're displaying b, so it is displaying you 24. Clear? But let's now try the same thing with these a, this type of 23. Let's see what happens. Okay, let me copy this part of the code and write it here so that we can play them side by side. Now here, instead of increasing the value of b, I'm trying to do the same thing with now a, that a equal to a plus 1, and then print a. Let's see whether it shows us 24 or something else. As soon as I execute this program, you can see it is not showing us 24, it is showing us an error. Don't worry about this error. Now it is a good idea that you become familiar with this type of common errors. So as soon as you see the error, you know actually what might be the possible reason of the error. So here what this error is saying, and we'll see your first thing is it is showing you that okay, this particular line where that error has occurred, or here this particular line where that error has occurred. And what error it is, the name of the error is type error, and it is saying that can only concatenate string not integer to string. It means, see, the first thing you should notice from this error, first thing you should realize from this message, error message from the Python interpreter, is that the Python interpreter is not trying to add a number this time. It is trying to concatenate a string. See here, when you concatenation of string means it is actually the same thing that you do with numbers, like adding two numbers means adding them up, like 5 plus 6 is 11. Concatenation is like similar string version of the same thing. Say for example, if you write ABC plus XYZ, it will simply do like ABC XYZ, that the string will become ABC XYZ. Okay, that is string concatenation. Now concatenation means joining two two strings. Okay, so now let's, what Python interpreter is trying to do, from this error we know that like it is trying to concatenate string with an integer. Now what is happening here? You see, a plus, now as soon as you write this plus symbol and one part of the plus symbol is a string, immediately Python will assume that this plus is not going, it is not the normal addition, it is the string concatenation, because one part of this plus, one operand of this plus operator is a string. And how does it know it's a string? Just by looking at its value. The value of this a is within double quotation 23. It means there you have stored a string. And since a is a string, you cannot add 1 with the string. Yes, you can concatenate 1 with the string. In that case, this 1 also should be a string. It cannot be a number. You got the point? See, if I don't write here this double quotation, then 1 will be a number 1 and a is now a string. A string plus a 1, that really doesn't make any sense. But a string plus a string, that makes sense to Python. Let's see how it interprets if I convert that 1, that number 1, to a string 1 just by putting this double quotation around it. So that time Python will not object it, and the output will come as 231. See, it is not doing normal addition. It is not doing 23 plus 1 equal to 24. Rather, it is doing string concatenation. It means it is joining this string 23. At the end of that 23 string, it is appending this new string a, new string 1. So as a result, you are getting the string 200. Not the string 231. You are getting the string 231. It is not 231. It is the string 231. Got it? See here, they could be anything. I mean, these a could have been any string. Say for example, u or like UYT, a number, and then again q. And then appending here, writing a plus 1 means what? It is not the addition, so there is no problem. We are just appending this string 1 at the end of this string UYT23q. So that time we will be seeing UYT23q and then 1 at the end. And this 1 also could have been anything, like say for example 675. It is not the number 675. So we are just trying to append the string 675 at the end of the string UYT23q. As a result, we're getting this particular thing. If you have understood up to this point, then let me quickly tell you a few more things, and then I'll come to the point like why you need to know about these data types now when you are actually trying to take input from the keyboard. Okay, but before that, let me tell you some few more details. Now see, I said you that this a equal to 23, it is this 23, like when you write it within double quotation, it's a string, and when you write b equal to 23 without any double quotation, it's a number. That I just said informally, but formally this string and this number, these things are called as your data types. Like different types of file, like if you see a file name as something like a.txt, it's a text file, a.png, it's an image file, a.jpeg, it's an image file, like that. The extension of the file tells you the type of the file. It tells you the data which is there inside those files. The same thing in a programming language also. In most of the programming languages, you will find the concept of data types. These data types actually tells what type of data it is. Okay, say for example, if I write b equal to 23, the type of the data, the type of this piece of information 23 is integer, and the type of this piece of information 23 within double quotation is string. Okay, there are some other basic data types also. This is not a video on data types, but then also these are simple concepts, simple things. You just hear it once and you will immediately understand it. Okay, let me tell you, like a equal to 23. If I write something like this, then this a type of this type of data 23, these numbers, integer numbers, right? Like a equal to 23 is integer, a equal to minus 23 is also an integer, like that. But if you write a equal to 34.54, but positive, see here, this number is different from b equal to 34. This type of number where there is no decimal part, they are called as integer numbers. But this type of number where there is a decimal part, like something, point something and something, so that time it will be called as a floating point number. These two types of data, they are stored differently in the computer memory. They are, the computer represents them internally. They are represented in a different way. So for that reason, they are considered as two different types of data. This type of data, they are called as floating point data. This type of data, they are called as integer data. And you have seen most probably, say for example, true false, right? They are also data types. They are also some sort of some type of data, true and false. This type, they are called as Boolean data type. And and again, say for example, if you write, say, let me write here, c is equal to true. So the type of this, this true value, this true, the type of that thing is equal to Boolean. I'll come again, I'll give you a concrete example. And say for example, I write d is equal to the number 23, but within double quotation. So that time the type of the data type, or the type of this particular piece of information is a string. In Python, how do you know what type of data it is? You simply can make use of this function type, and then suppose you want to know what type of data this variable a is holding. So if I write type of a, then it will tell me, okay, the type of a is float. See here, I said if this is a floating point number, and these what you call that real numbers, no, they are floating point numbers. If I write minus 34.54, then also it's a floating point number. What is the type of b? Say type of b is, here in this case, it's an integer, so it is integer. int is a data type, so it's an integer data type. They could be both positive, negative, but they are integer data types. Okay, like 34 is an integer. C is equal to what type of, like this true and false, what type of data they are. So I can write type C, it will tell me, okay, they are Boolean data types. Boolean short form is bool. Or even you don't have to store them, and like if you want to know the data type of a piece of data, you don't have to store them in a variable first and then check the the type of that variable. No need actually. You can directly write here, okay, I want to know what is the type of this what is the data type of this piece of information, true, then, or this piece of data true. It will saying true is actually Boolean type of data. And then say for example, directly I write here 78.79 78.76, okay, that's wrong, 78.76, and it will tell me, okay, it's a floating point data, right? And say for example, only if I write 78, that's a integer data. But if I write 78 within double quotation, then you will see, okay, it's a string data type. It's a string data type. String, it's a long, that's complete word for us humans, and for this Python interpreter, it is str. Clear? So these are why we need these different types of different data types, because these different types of data, like when you specify 34.54 in a program, they're stored in a different way. The storing mechanism is actually different than they store the number 34 is stored, or this number 34 is stored in a different way than this number 34 within this double quotation is stored. Okay, internally they are represented in different ways. So for that reason, we have these different data types. Okay, these are not the only data types, but these are the basic data types that you will be that you will find in Python. And this list thing, right? List, list, list is also a data type. Say for example, let me write here a is equal to, say, a list 1 comma that contains, again, you see, a list can contain any type of data. 1 is a number, 23 is a string, and then 54 is again a string, and then 7.8 is a number again, a floating point number. And then I want to know what is the data type of A as a whole. Okay, so I can write here type, and then let me write here the name of the variable A. And then see here what it will show me. It is showing me that it's a list. The data type is list. Like list is a inbuilt data type in Python. Like, see, what are different inbuilt data types? These are inbuilt data types. Okay, there are some data types that you can create also, that will come later on. This we'll know about them in the coming videos, but for the time being, that's not our main point. Again, we are not talking about, our main goal was not the data types. Actually, our main goal was input function, but they are this concept is very much related to the input function, so you must have to know them before actually using the input function. Okay, so done. Now from here what we learned is, okay, our main point is writing d equal to 23 within double quotation. When we write it becomes a string, but if I write d equal to simply 23, it becomes a number, an integer number more specifically. Float is also a number, integer is also a number, but integer means integer, float means integer. After that there are some decimal part, like fraction is there, right? I guess you know what I'm saying. Okay, done. Now once we know this, now see here, once we know this, then what we can do is I can show you this code. Now I'm coming to the point. Now what we can do is, say for example, I'm writing here a is equal to input, and that's all. And then I want to know now what type of data the user has entered. Okay, so what am I doing is, I'll immediately after the user enters something from the keyboard, immediately after that I'll compute the type of the data, and then I'll automatically it will come on the screen. Actually, I don't have to display it. So type of the data. So for example, I write here xxx. Okay, and then I press enter. As soon as I press enter, it will go to A, and type of A is string. No problem, type of A is string. XXX is a string. Okay, fine, good. Again, I'm executing this program, and then this time I'm writing 23. It's a number for us, but I'm entering it. It will go to A, and then type of A is string. It means what? Whatever you enter from the keyboard, no matter what you enter, what you type from the keyboard and press enter, everything will be considered by Python interpreter as a string. So in the wherever you store it, they will be stored in the form of a string, because Python never knows, right? I mean, whether you are going to enter a number, you're going to enter a pure string, or what it is that you are trying to enter, right? So string is sort of like general format. I mean, anything. It could be a number can also be represented. A number can also be represented by a string, or an alphanumeric character set can also be represented by a string. So everything is considered as string. Whenever you enter something from the keyboard, input function will read them as a string. Later on, if you need them to change, like say for example, now if it is a string, then we cannot perform these operations, right? I mean, we know that A is a string, so certainly writing A is equal to A plus 10 is not possible, because A is a string. Now we cannot simply add 10 with a string. Suppose we want, our goal was like whatever the user enters, we'll add 10 with it, and then we'll display the output on the screen. So simply we cannot do something like this. Why you cannot do? Because we know that the type of the entire thing will be considered as a string. As soon as we know that, we now need a way. And the next question is, yes, obviously that's the question that should come into your mind. Like, okay, then no problem. How do we convert a string to a number? Okay, let's see here. Suppose now we want to convert whatever the user enters, we want to convert it to a number. So for example, A is equal to, I write here input, whatever the user enters, I'll first store it in A, and after that, what I'll do is I'll use another variable, say B, and then I'll try to convert it to an integer. So I'll write in this way. Integer is a function that converts a string to an integer. Clear? What am I doing is, see, integer is a function, and that converts whatever you write here, that will be converted to an integer. And yeah, that's all this integer function will do. Let's say for example, whatever the user enters, I have stored it in A, so I can write here A. It means, what am I doing is, first our program will ask the user to enter something from the keyboard. Whatever the user enters from the keyboard, it will go to A. Once that is done, the program will now try to convert that a to an integer number, and that integer number will be stored in b. And later on, if we want to perform like b is equal to b plus 1 type of operation, then it should be possible. And then if you want to print like what is the new value of b, then done. So if everything is fine, then what will happen is when I execute this program will wait for the user to enter something from the keyboard. And if I enter a number from the keyboard, like say for example 67, then what it will do is that 67 string version will be stored in A, and then that 67 string will be converted to a 67 integer number. And that 67 integer number along means with that 67 integer number 1 will be added, and that, so obviously it will become 68, and then 68 will be stored back in b, and then we are printing b, so we'll be able to see 68 on the screen if I enter a 67 from the keyboard. Yeah, 68, it is working fine now, right? I mean, see the difference here. Let me write the code once again. See the difference. If I don't write this b is equal to int a, simply we write here b is equal to a, whatever the user type, the same thing is stored in b. So that time it is not possible, because b will also be here. If I write 67, b will again be a string, so it will be trying to do, Python will see it like, okay, a string concatenation it will try to perform, but here you're writing a 1 as a number, so it will again fail to do that thing also. So as a result, it will throw this error on the screen. Got it, the difference here? But here what we're doing is b, we are converting whatever the user has entered. We first stored it in a, and then we converted it to a number, and that number, integer number, and that integer number we have stored in b. Since b is a number here, there is no problem adding 1 with it, so it can smoothly do it. And then as a result, you can see one increased value. Whatever the user enters here, it will if I enter 0 here, it'll show me a 1. If I enter, say for example, minus 100, it'll show me minus 99, okay, on the screen. Similar to the int function, there is another function that is called as float, okay? And as you can guess what this float function will be doing, it will be converting a string to its equivalent floating point number. So for example, let me give you, no matter whether that string is coming from the keyboard or you explicitly have created a string variable and then you're trying to convert it, in both these cases things are same. What I mean is, say for example, instead of taking the input from the user, now what I do is I store x is equal to a number. Say for example, let's see it with integer, then I'll come to the floating point numbers, okay? Say for example, x is equal to 12, and then you can write it in these ways. Say for example, y is equal to, first convert it to an integer, that x, the string x you want to convert to an integer, the result you are storing it in y, and then y becomes a number. Then you can perform any numerical operation on y. Say for example, you can write y is equal to y plus 100, okay, and then you can print y. That's all. I mean, I run it and I check it. The output is 112. Initially it was 12, the string, then this will convert that string 12 to a number 12. Then with the number 12 you're adding 100, you're getting 112 that you're storing back in y, and then you're printing y. And again, before actually going to the float function, let me tell you one more thing here. I did this thing, like first I stored string to a, that string 12 to a variable, and then that variable I converted to integer, and that again I'm storing in another variable and all. I'm doing it in step by step, but one can write it in a single instruction also, like this. Say for example, say y is equal to y plus whatever it is the value of y, or sorry, y is equal to y. First you want to convert the string 12 to a number, and then along with that you want to add 100, and you don't have to even store it in y. You directly can write print all this will give you the same output here. Okay, but this is for beginners. I think this approach is much better, because you should learn all the steps clearly, and once you become like familiar or comfortable with all these, then you can go with this way of writing the code, like putting many instructions in the same instruction, sort of in the same line at least. Okay, having said, so now as I said, no, like similar to this int function, there is another one, that is the floating point function. Let's see it here. I created it in the wrong place. let's create a code block here, and then I write, say for example, x is equal to a number 12, I mean string 12, and then I write y is equal to, now what I want to do is I want to convert it to a floating point number. So for that reason I'll be writing the and I'll be calling the function float instead of integer, and here I'll be passing this x, and then I'll be printing, say, print y, the number y. Okay, and let's run it and check it. So 12.0. See, as soon as this string 12 is converted to a floating point number is a real number. I mean, it has this fractional part. So 12 will be converted to 12.0. Integer 12 is only 12. And say, for example, I write here z is equal to integer of the same string x. So y is the float of the string, the same string, float representation of the same string 12, and z is the integer representation of the string 12. And then I am printing both x and sorry, y and z on the screen separately. Let's see the output here. See, y is 12.0 because it is the, when using float function we are converting 12 to a number, so that's why 12.0. And z is 12 because using int function we are converting a number to converting a string to a number, so that's why it is 12. Okay, a float function is, I guess, it's more general, because say for example, if I write here x is equal to 12.43, and then if I write y is equal to integer and then x, and then print print y, this time if you see, I'll show you an error here, invalid literal for integer which with base 10, 12.43. Because of this decimal point here, that's a problem for the Python interpreter. Like when you call, when we're using it with, when you're trying to convert that string to an integer, 12.43, because for Python it is confusing. I mean, 12.43, it cannot be converted to a number actually, I mean to an integer number. So for that reason it is showing you this value error. But if you, instead of converting it to like using integer function, if you use this float function, things will be normal. I mean, 12.43. See, float will work with integer also. Like if I give 12 and then I'm trying to convert it to a floating point number, it can be converted because 12 is equivalent to 12.0. So it can be converted. So I guess float is more like general than integer. But if you specifically need to convert it, like explicitly, like your requirement is that always the entered number should be an integer, in that case you have to use this int function to convert it. But if it is a number that you want to convert, like it could be anything, a decimal, I mean, a real number or an integer number, in that case I guess float is more appropriate. In this specific example here, like addition of two numbers, I guess float is more appropriate than integer, because user might enter the number as 12.50 also. And if you use integer, in that case, 12.50 cannot be converted to an integer. It will end up with an error here, right? So for example, as I said now here, what I mean is, okay, now I guess let's directly write the code for this one, and then we can discuss the details about the program. Okay, so the same program we'll be writing. So I'm copying it and then I am pasting it here. And now these a and b and all, we want to take it from the user. So I want to get rid of all these, a equal to 30, b equal to 30. Okay, let's do it in this way. Instead of storing 10 directly here, what we'll do is a equal to, I'll ask the user to enter the number. So enter the first number. Okay, and then for b also the same thing, ask the user enter the second number. And directly we cannot write c equal to a plus b. If we write c equal to a plus b, what it will do is whatever the user enters, it will just concatenate both the numbers side by side, and it will display the output as a string. Let's first try with that. Let's like run this program and write the first number as 10 and the second number as 20. And see here, the output is coming as 10 plus 20. Here 10 is a string, 20 is also a string. I mean, a is a string, b is a string, so a plus b means string concatenation is happening. As a result, you will see 10 plus 20 means 10, 20 put together side by side, and that's the output. I guess people can comprehend now this thing. And what we want is that we want our number numerical operations, isn't it? So for that reason, what we will do is we'll first convert these a to a number. So let me call it, say, an. I mean a, the numerical version of a. So I'm converting it to a floating point number first, float, and then whatever the user writes in a. And similarly, the numerical version of number version of b, I'm storing it in a variable bn, and using this float function, I'll try to convert whatever the user enters for b, I'll convert it to a floating point number. And if both these two numbers are entered properly by the user, then at the end c will be the sum of an and bn, and at the end we will display the sum of these two numbers on the screen. Let's run this program and check. So enter the first number. So I'm entering here the first number as 10 and the second number as, say, 20, and this output is coming as 30.0. Why it is so? Because C is the sum of two floating point numbers. That's why the output is coming as 30.0. Got it? Now let's run, say, for example, the first number as 1.1, the second number as 2.1. Both of them are valid floating point numbers. So 1.1 plus 2.1 is 3.2. So 3.2 is coming on the screen as an output. Done. Now, more or less everything is done. But one question should still be there in your mind, like when you are following this video at this point also. And the question should be, what if the user enters something that cannot be converted to a number? I mean, say, let's run this program. I mean, the user can enter easily, say, for example, the user is maybe not intentionally, say, for example, the first number is enter the first number 1.1. The user was about to enter 1.1, but by mistake he or she has written 1.1x. And as soon as I press enter, obviously it will ask for the other number also, b, and b, suppose the user enters properly as 2.1. Now what will happen the next? As soon as I press 2.1 and enter, this 2.1 will go to b, and 1.1x is already there in a. After this line, this float function will try to convert a to a floating point number. And what is a? A is 1.1x. 1.1x cannot be converted to a floating point number, isn't it? And that's where the problem is still there. I mean, if the user gives wrong input, the program will break down actually. You see? The program is up to this point, everything was fine, but as soon as the Python interpreter is trying to execute this particular line here, an is equal to float of a, there it is finding a problem. Could not convert string to float 1.1x. The error message is quite clear. I mean, here it is saying that 1.1, I don't know how to convert 1.1x to a floating point number. And that's why there is no point of continuing further, and the program ends with these error messages. That problem is still there, right? We might want to solve that problem also, and if we can solve it, then our program will be sort of perfect. And for that reason, how to solve this problem actually? I mean, if the user enters something which cannot be converted to neither an integer nor a floating point number, what should we do in that case? And that topic is actually outside the scope of today's video actually. The way we solve that problem, that particular mechanism is outside the scope of this discussion. So, but then also for those people who might want to know, who are interested actually, okay, how to solve it. I mean, no matter whether it is within the scope of this video or not, we want to know. So for those people, yes, you can do something like this. You have to make use of something called as exception handling. Okay, and that is what I say. Okay, let's see it actually. Exception handling means, this type of situations are called as exceptional situation. Exceptional situation in the sense this problem will occur. This program is fine. You cannot say this program is wrong. This problem will occur only when the user gives the wrong input. If the user gives the right output, right input, the program is working fine. Exceptional situation will happen when the user enters wrong input. So in programming, in any program, I guess in most of the programming languages, this concept of handling exceptional situation is there. Exceptional situation. It is not a normal situation. It is an exceptional situation. And if that exceptional situation happens, what you want your program to do? I mean, you always can if you don't handle those exceptional situation in programming, then the program breaks down at that point. But when those exceptional situation happens, we don't want our program to stop there. We want our program to handle that situation gracefully and then move further. And the solution or the mechanism through which you do this thing is using this exception handling process. And in Python, you do it with the help of this try and except block. Okay, let's see how to do it. Again, as I said, now this thing is outside the scope of this video, so I'll simply show it to you like how we can solve this problem, and in some other coming videos we'll be talking about this exception handling in more details. Okay, let's see. Say for example, we have this x is equal to, say, a number, not a number actually, 34 point rt, and then we try to convert it to a float. Okay, and then we pass here x, and we're trying to convert x to a floating point number, and we know that here this is a problem. I mean, it cannot be converted to a floating point number. So in that case, what you do is, instead of writing, like, like sometimes this will work, sometimes this will not work based on the value of this x. Okay, so and that you will come to know only when you execute the program. So it means this particular line might cause an exceptional situation here, like try it. So for that reason, you'll write this line inside this try block. Okay, like try colon and then y is equal to float x. It means you're sort of saying that, okay, you are asking the Python interpreter, you first try to do that thing. Okay, if it can be done normally, there is no problem. But if it cannot be done, except if there is an exceptional situation, you will be doing something like this. Say for example, you just show a message to the user like print enter a valid number, and or suppose the number is not valid. Say for example, the number is not valid. Okay, something like some message you want to display to the user. And if it is normal, then you just display the number on the screen, like, okay, it can be converted and this is the converted number. So in this case, suppose for example x is equal to 34 point rt, so we are this particular line will be executed, y is equal to float of x. It means the Python interpreter will first try to convert these x to a floating point number, and since it cannot be converted, it will become an exceptional situation, and since it becomes an exceptional situation, it will display you the number is not valid. See here, as soon as it becomes an exceptional situation, it will not execute any of the line which are there below that particular line. So print y is never going to be executed in this case. So let's execute the program and check the output. The number is not valid in this case. It's coming like that, right? When the number is not valid in this case. I'm saying the same thing twice. But suppose the number is valid now, say 09. Okay, in that case, what will happen? 34.09. You are asking Python interpreter first try to convert it to a floating point number, and 34.09 can be converted to a floating point number smoothly. So there is no problem, right? No exceptional situation. So the result will be stored in y. Since there is no exceptional situation, print y will be executed. As a result, you will see 34.09 on the screen. And this exceptional part, like the block of code that you wrote for exceptional situation, that part certainly will not be executed because there is no exceptional situation at this time, right? So as a result, you will see 34.09 on the screen, right? Now, how we can apply these here? We can apply it in this way. Say, okay, let me rewrite the code. I mean, I can do it in this way. Should I rewrite? I should rewrite, right? I'll do it in this way. Okay, let's do it. Okay, first ask the user to enter the first number. Input, enter the first number, and store the number. Store whatever it is that the user has entered in a variable, say a. And then you try to convert this a to a floating point number, because if the input is wrong, there is no point of asking the user to enter the second number, right? So first you check whether this input is right or wrong. And how do we do that? First we write something like this. We write try, and then we write like ask the Python interpreter first try to convert this a to a number, floating point number. So for example, an is equal to float of whatever it is in a, and if it can be converted smoothly, then we want to do something. And if it cannot be converted smoothly, then what we want is we want to execute this except block, and there we will be printing print, say the entered, the first number is wrong, or the entered number is wrong. Okay, so number 1, suppose this message is coming from number 1, so that's all. But suppose if that number is okay, suppose the user has entered a valid number which can be converted to easily to a floating point number. In that case, it's time to ask the user for the second number. So do the same thing, like use the input function to take the input from the user. That is, ask the user like enter the second number, number, and whatever it is that the user enters, you store it in B. And then again try to convert it, try and bn is equal to float of whatever the user has entered for B. And if it is a normal situation, then it's okay, we'll come to that point. But if it is not a normal situation, if suppose the user has entered something that cannot be converted to a floating point number, in that case what we want is we want to execute this except block, and there we want to display, say print the second number is wrong, the second number 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 is wrong. Okay, but if it is a normal case, I mean suppose B can be converted to a number, suppose the user has entered B also properly, in that case what we want to do is, yes, in that case you are ready to we can actually display the output there, right? So in that case we want to compute the sum of an plus bn, and then we display the sum on the screen. Okay, now let's execute this program and check it, like what happens when we do things like, say for example, enter the first number. I enter the first number itself as a wrong number, so 10.io. What will happen if I enter 10.io, enter the first number, this 10.io will go to A. Okay, up to that point everything is fine, and then this try block will be executed, which will try to convert this A, that is 10.io, to a number which cannot be converted. It means exceptional situation will occur, and since an exceptional situation will occur, it will skip everything after it. Okay, everything, yes, this entire portion will be skipped, and it will execute this except block. See here, this except is for this try and this except is for this try. You should realize that point. Okay, and it's not a very hard thing to notice. Because of this indentation, it is very much clear that this except is is the part of this try block, and this except is the part of this try block, right? So anyhow, if there is an exceptional situation here, that is if A cannot be converted to a number, immediately this corresponding except block will be executed, and as a result you will see the entered number is wrong, number 1. Since I have entered the first number itself is a wrong number, so this A cannot be converted to a number, an exceptional situation will occur, and as a result it will end up with displaying me this particular message on the screen. And that will be the end of the program. You can see here, after this, once this except block is executed, it will not go back here and again execute the program. After this is the end of the program. See, as soon as I enter, the entered number is wrong, number 1. It means this particular line is getting executed, and that is the end of the program. There is no point of continuing if the user has entered the first number itself is wrong. Okay, now let's again re-execute the program, and this time I enter the first number as a valid number, like 1. 1 can be converted to a number, I mean a floating point number, right? So this I have entered 1, so this is stored in A, and then A can be converted to a number, can be converted to a floating point number. So 1 is converted to a floating point number, and it is stored in B. Then it is executing this particular line, enter the second number, and as a result I'm seeing this line on the screen, like enter the second number. Say this time I enter the second number as a wrong number, 5.44. Instead of, suppose I had to write 5.4, but I wrote 5.4. In that case, these whatever I typed, it will be stored in B, that is okay. But the next line, what we're trying to do is we're trying to convert that B to a floating point number. Certainly 5.4 cannot be converted to a floating point number. As a result, this particular line will cause an exceptional situation which will be handled by this particular except block, right? This is the corresponding except block of this try block. And once so as a result, what will happen is it will execute the second number is wrong, but this particular print statement will be executed. And once it is executed, that is the end of the program. I mean, after that, nowhere to go, right? So as a result, if I press enter here, it'll show me the second number is wrong. That's the end of the program. So if now let's give both the numbers as right, say for example 1, the second number is also right 2. In that case, what will happen? If I give the second number is also as right, so this can be converted to floating point number, which is stored in Bn. Then C is equal to An plus Bn. So 1 plus 2 is 3. Print C is, it is going to print C, the value of C is 3, that is 3.0, because all of them are floating point numbers. So the result will come as 3.0. Got it? So this is how you can handle that that situation. Like if the user enters wrong numbers, then how do you do that, right? And I guess these are things that you have to take care of when you're using input function. Taking the input from the keyboard is not a big deal. You can use the input function. But the thing is how you want to use the input, that matters. Like whether you want to treat them as numbers, and if you want to treat them as numbers, then this conversion mechanism must be there. Like if you want to convert it to an integer number, then you convert it. If you want to convert it to floating point number, then you have to convert it to floating point number. And again, there could be some exceptional situation, like whatever the user has typed, that might not be possible, to even convert to a number. So in that case, those situations you must have to handle using this try catch block. I mean try except block here, and that's all. If you know these things, then you can use this input function anywhere you want. Okay, that much only in this part of the video. So we have learned the input function, and also we have learned like how we can convert the accepted string from the keyboard to a numeric version. And if we cannot convert them, what to do, that also we have learned. And that's all. We are now we'll be using this input function in the coming videos. So I request you people to digest this video properly before actually moving to the next video. Okay guys, then that much only in this part of the video. See you guys with some new content in the next video. Till then, have a nice day.